What we want is the ability to model motion. We want to consider an object and be able to come up with a mathematical model that represents how the object moved. And it doesn't really matter what this is. It might be dropping an object off the side of a cliff. It might be considering a car as it drives past us. Or, as we're going to look at in this video, it could be a cart moving along an air track at a constant velocity. With all of these situations, what we want to do is we want to know where the object was at a certain point in time. With the video, we're going to be able to create a table of values, very similar to how we would do in math class, except now we're representing the position of the object and its time. Armed with this information, we can go and create a position time graph. And so as we watch the object go from left to right, we're able to create a series of points that represent where the object was at a given moment in time. As we consider these points, we see that they're fairly linear. And so what we're going to do is we're going to use a line of best fit. We draw our line of best fit, and we see that it is a good representation of these points. We can now consider 2 points on this graph and consider the displacement over the time, or, as we would call it in math class, slope. From the standpoint of physics, we're going to call this velocity, and when we calculate it in this case, we get about 6.8 centimeters per second. So now we can represent the object's position as 6.8 centimeters per second times time, plus where it started, in this case, 0 meters. The production of these videos has been generously supported by the Nova Scotia Teachers Union through the Program Development Assistance Fund.